Oh, hello dear students. So in this video we are going to discuss a few simple examples from Faraday's law of electrolysis, what kind of numericals you can get from Faraday's law of electrolysis. So I will keep it very simple so that it's easy for you to understand. I will take a few examples from NCERT regarding on the topic Faraday's law of electrolysis. Okay, so first there is an example from NCERT, a simple example that there is a solution of copper sulfate solution, CaSO4 solution, and it is electrolyzed for 10 minutes. It is basically example number, if you have a new book then it may be 2.10, example number 2.10. I have an old book that in that it is 3.10, but in the new book it might be 2.10. There is a copper sulfate solution which is electrolyzed for 10 minutes with a current of 1.5 ampere. So electrolyte, just 1 minute. 10 minutes with a current of 1.5 ampere. So what mass of copper will be deposited? That is the question. Okay, so a simple question. Copper sulfate solution. There is a copper sulfate solution which is being electrolyzed for 10 minutes with a current of 1.5 ampere. So what is the mass of copper deposited at cathode? I told you metals are usually deposited at cathode only. So how to approach? Now see, this can be solved in two ways. First, I will tell method 1. You can choose any of the method, both are equally acceptable. So first, if we have copper sulfate solution, in that copper will be in +2 state. Okay, so we have copper in +2 state in aqueous solution, and it accepts 2 electrons at cathode, gets reduced to copper metal. So this is how it gets deposited at cathode. So copper sulfate, it has copper 2+ ions which accepts 2 electron, gets reduced at cathode. So first we have to determine the equivalent mass of copper in this case. So what will be the equivalent mass of copper? So you must know it is atomic mass by valency factor. So I am writing the formula also. It is atomic mass for elements, it is atomic mass by valency factor. So atomic mass of copper is 63.5 and the valency factor here will be 2. Why? Because it is accepting 2 electrons. Since copper is accepting 2 electrons, so valency factor generally it is represented with n. Valency factor is represented with n. So that is why n is 2 here. Number of electrons the copper ion accept, it is 2. Right? So E here is the equivalent mass of copper is 63.5 upon 2. We can write it as 31.75, or we can simply leave it as 63.5 upon 2. Now, so Z will be, the electrochemical equivalent will be E upon, we know it is E by F, or we can say E upon 96500. So E was 31.75 divided by 96500. So that is the ECE of copper. ECE of copper, right? That is electrochemical equivalent of copper. Now we need to calculate the mass of copper. So mass of copper is electrochemical equivalent into current into time. So electrochemical equivalent we already know, 31.75 upon 96500. This is the electrochemical equivalent. The current was given to be 1.5 ampere and the time is given to be 10 minutes. Now you have to convert into seconds. I told you when we apply this formula W equal to ZIT, time must be in seconds. So 10 into 60, so that will be around 600 seconds, right? So this is 600 seconds. Okay, so now when you solve this, you will get the answer. It is around 0.2938 gram, that is given in the NCERT. Okay, so this is one way of doing it, right? We applied the formula in this way. We applied the formula, right? Now coming to the second method, method 2. So in this method, first we will calculate the Q, that is current, charge, current. Charge is current into time. Okay, so in the second method we have to first calculate the charge passing through the electrolyte. So it is current into time. Current given is 1.5 ampere and time is 600 second, so it will come out to be 900 coulomb. 900 coulomb. So this, next, if you write that equation again, copper 2 plus ion accepting 2 electrons to give you copper metal, right? So one copper atom is formed when the ion accepts 2 electrons. When the ion is accepting 2 electrons, it forms one copper atom, right? So if it accepts 2 mole electrons, it will form 1 mole atoms. I hope it is clear. So when the copper ion accepts 2 electrons, it forms 1 atom of copper. Now when it accepts 2 mole electrons, it will form 1 mole atoms. Now the charge on 2 mole electrons will be 2 Faradays, because the charge on 1 mole electron is called 1 Faraday. So for 2 mole electron it will be 2 Faradays, and the mass of 1 mole copper will be its atomic mass, that is 63.5 gram, right? So 2 Faradays of electricity can produce 63.5 gram of copper. So 2 Faradays, 2 into 96500, 2 into 96500 coulombs. So 2 into 96500 coulombs of electricity produces 63.5 gram of copper. So 1 coulomb of electricity will produce 63.5 upon 2 into 96500 gram of copper. Now in the question it is given that we have 900 coulombs of electricity, so that will form 63.5 upon 2 into 96500 multiplied by 900. So these many grams of copper will be formed. Now if you see, it is similar to the answer comes out to be similar. Obviously it will be similar, the process is different, the answer will be similar only, so it will be similar. Okay, so see, so in this method we are not applying the formula directly, we are just calculating the charge first, and we are using the unitary method to determine that from the charge which is passing through the electrolyte, from that amount of charge, what amount of copper can be deposited. Okay, now we will take another question. It is the in-text question. So it is the in-text question of NCERT. In the new book it will be 2.10, I think so. So if a current of 0.5 ampere passes through a metallic wire for 2 hours, so current is 0.5 ampere passing through a metallic wire for 2 hours, how many electrons would flow through the wire? So the question is, how many electrons would flow through the wire? So this is the question. Okay, so first you have to understand the question. It's a simple question again. So since the current is 0.5 ampere, so we have to first calculate the total charge that is passing. So charge, that is Q, that will be current into time. Now time obviously should be in seconds. So current is 0.5 ampere and time in second will be 2 into 60 into 60. 2 into 60 into 60. 2 hours. So we have to convert it to seconds. So we have to multiply with 62 times. So this will be the charge in coulombs. So I will quickly calculate. So it is going to be 3600, I think so. 3600 coulombs. So these two will get cancelled out. Okay. So this is the charge that is passing through. Now you must have learnt in physics that total charge is n number of electrons into charge on one electron. Q is equal to Ne. So the Q is the total charge Q is the total charge, N is the number of electrons, and E is the charge of one electron. Okay, so from here you can simply calculate the number of electrons, that is N is equal to total charge by charge on one electron. So Q is total charge is 3600 coulombs, and charge on one electron is 1.602 into 10 power minus 19 coulombs. Okay, so simply from here you will get the number of electrons that passes through the conductor. So I will quickly calculate the answer. 3600 divided by 1.602 divided by 10 power minus 19. So it comes out 2.247 multiplied by 10 power 19 electrons. I am very sorry, electrons. Okay. So this is how you can calculate. Okay, so first we calculated the total charge that is passing through the conductor, and from using this formula, by using this formula we calculated the number of electrons that passes through the conductor, that is total charge by charge on one electron. Now coming to the another question, that is the next question, 3.12. In your book it might be 2.12. I think I've done a mistake in the question here. It should be 10 power 22. I will calculate this once more. 2.247 into 10 power minus 22. So it is, take a note of this. This is 10 power minus 20, 10 power 22, not minus 22, 10 power 22. Okay. Now coming to another question. That is basically the 3.12. Basically it will be 2.12 in the new book. 2.12 in text. 2.12. So it says there is a reaction, dichromate Cr2O72 negative plus 14H plus 6 electrons, giving you 2Cr3 plus 7H2O. So the question says, what is the quantity of electricity in coulombs needed to reduce 1 mole of Cr2O72 negative? So what is the quantity of electricity in coulombs needed to reduce 1 mole of dichromate, right? So this is the question. Now see, from the reaction that is given, from the reaction itself, you can say, from the reaction itself you can say that 1 ion of dichromate, so 1 ion requires 6 electrons for its reduction. So 1 mole ion will require 6 mole electrons, right? In the question it says only 1 mole ions or 1 mole dichromate. So 1 mole ions will require 6 mole of electrons. Now the 6 mole electrons means 6 Faraday. The charge on 6 mole electrons will be 6 Faraday. So just 6 into 96500 coulombs. That is your answer. Okay, 6 into 96500 coulombs. That is your answer. So that is your answer. So it is 579,000 coulombs. Okay, so this is your answer. Very simple question. Very simple question. 579,000 coulombs. Now I will take some question from the exercise also. So from the exercise I am taking question number let's say 3.12, so it will be 2.12. From the exercise the question is, it will be in the new book it will be 2.12. So 2.12, question number 1 I am taking. So how much charge is required for the following reduction? So to reduce 1 mole aluminium 3 plus to aluminium, how much charge will be required? So that is the question. So again a very simple question. These kind of questions sometimes they give you in the CBSE kind of exams also. So if you have aluminium 3 plus, it obviously takes 3 electrons to get reduced to aluminium metal. So one ion, basically one ion, if you have only one ion, so one ion requires 3 electrons. So 1 mole ions will require 1 mole electrons, and 1 mole electrons, the charge will be 3 mole electrons, so the charge will be 3 Faraday. So that is your answer, either 3 Faraday or 3 into 96500 coulombs. Okay, so to reduce 1 mole aluminium 3 plus ions to aluminium, you need 3 mole electrons. So 3 mole electrons is 3 Faraday or 3 into 96500 coulombs. Now you can find out the exact answer by just multiplying. I hope it is clear. Now I will take another question. Let's suppose 2.13. So this is clear, this is an easy example, so I'm quickly moving to another question. 2.13. How much electricity in terms of Faraday is required to produce 40 gram of aluminium from molten Al2O3. Okay, so to produce 40 gram of aluminium from molten alumina Al2O3, how much electricity is required in Faradays? How much electricity is required in Faradays? So now again, if you see Al2O3, in Al2O3 aluminium is there in +3 state, or better to write 3 positive state. So aluminium is there in 3 positive state. Okay, now if you see Al3 plus will accept 3 electrons to give you aluminium metal. Okay, now to produce 1 aluminium ion or 1 aluminium atom, so for 1 atom, so produce 1 atom we need 3 electrons. So 3 electrons can produce 1 atom of aluminium. Now if you have 3 mole electrons, then it will produce 1 mole of aluminium. 1 mole of aluminium, right? So 3 mole electrons will be 3 Faraday, and for 1 mole it is 27 gram. Aluminium is the atomic mass of aluminium is 27. So for 3 Faraday is required for 27 grams. So we can write 27 gram aluminium is produced using 3 Faraday of electricity. So 1 gram will be produced using 3 by 27 Faraday. So if we have 40 gram aluminium, so 40 gram aluminium will be produced by 3 by 27 multiplied by 40 Faraday. So that's going to be 40 upon 9 Faraday. So that will be 4.44 Faraday. Again a simple question. Okay, so to produce 40 gram aluminium, the question says to produce 40 gram of aluminium from Al2O3, how much Faraday of electricity is required? So from the equation only we know that in the alumina, that is Al2O3, aluminium is in +3 state, so it requires 3 electrons to get reduced to a aluminium atom. So 3 electrons produce 1 aluminium atom, 3 mole electrons will produce 1 mole aluminium atoms. Okay, 3 electron produces 1 atom, so 3 mole electrons will produce 1 mole atom. So 3 mole has a charge of 3 Faraday, and 1 mole of aluminium will be 27 gram because the atomic mass is 27. So 27 gram aluminium produced from 3 Faraday, 40 gram will be produced from 3 upon 27 into 40 Faraday. So this is how we can calculate. So I will take the next question. So you can solve more questions. If you find any difficulty, you can let me know. I will solve that question for you and upload the video. So I will take the last question, that is 2.16. So we have 3 electrolytic cells, A, B and C. 3 electrolytic cells are there. The first one containing zinc sulfate, second one containing silver nitrate, and the third one containing copper sulfate. So we have these 3 cells. They are connected in series. The current is passing 1.5 ampere through all of them. A steady current of 1.5 ampere passes through all of them until the mass of silver getting deposited is 1.45 gram. Now we need to calculate the time first. Then we need to calculate the mass of copper also and mass of zinc also that is going to get formed. So this is not a difficult but a lengthy question, big question. Too many things are going to be calculated in this case. So we have 3 cells, 3 electrolytic cells, first containing zinc sulfate, second silver nitrate, third copper sulfate, which are connected in series. The current passing through them is 1.5 ampere and the mass of silver getting deposited is 1.45 grams. So we need to first calculate the time for which the current flows, and then we need to calculate the mass of silver and mass of copper and zinc that is getting deposited. The mass of silver is given. The mass of silver that is getting formed is given in the question. We need to calculate the mass of copper and zinc. So simply first thing that we need to do is to calculate the equivalent masses of all 3. The equivalent mass of zinc will be, its atomic mass is 65.3 upon the valency factor will be 2 because zinc is in +2 state, so it will accept 2 electrons. Silver is in +1 state, so it will accept 1 electron. Okay, so the equivalent mass of silver will be 108, approximately the atomic mass is 108 by 1, and the equivalent mass of copper will be 63.5 upon 2. Now because again copper is in +2 state, right? So this is what we do first. That will make our further it will be easier for us to approach. Now first we will calculate the time for which the current flows. So from the first law, using the first law of electrolysis, we know that W equal to Z into I into T. And so far we are applying for silver because we know the mass of silver that is getting formed here. So we are applying first law for silver. So mass of silver will be equivalent mass of silver, Z is E by 96500, current into time. So we need to calculate the time here. So time will be mass of silver multiplied by 96500 divided by equivalent mass of silver multiplied by the current. So from here you will get the time for which the current flows. Okay, I hope I have not done any mistake here, right? Okay, so the mass of silver that is getting formed here is 1.45 gram. So I will simply write 1.45 gram here. multiplied by 96500 divided by equivalent mass of silver was 108 and the current is 1.5 ampere. That is already given in the question. Equivalent mass of silver is 108 only and the current is 1.5 ampere given in the question itself. Okay, so this will be the time in seconds. Remember, the time always that we get from this equation will be in seconds. So I will first using the calculator, I will calculate it quickly. 1.45 into 96500 divided by 108 divided by 1.5. So it is 863.734 seconds. So this is the time. You can also convert this into minutes or hours also if possible, but not necessary. If it is not asked in the question, then it is not necessary. I think it is not asked in the question. They are just asking how long did the current flow, so it is not required to convert into minutes or hours. Not required, but you can convert if you want. So 863 divided by, if you want to convert into minutes for example, so it will be 14 minutes. It will be approximately 14 minutes and some seconds. I will so around 14 minutes 23 seconds. Okay, so you can convert, but it is not compulsory. Now coming to the second part, that is we need to calculate the mass of copper and mass of zinc also found. So you can now, since you know the time, you can also apply the first law for both of them, copper and zinc, and from there you can calculate their masses that are going to get formed. But you can use the first law. It is not necessary that you use second law only. You can use the first law also to calculate these two masses, W equal to ZIT. You can apply that also, but I will solve it using the second law. So using the second law, I can write, using the second law of electrolysis, I can write that mass of zinc upon equivalent mass of zinc must be equal to mass of copper upon equivalent mass of copper must be equal to mass of silver upon equivalent mass of silver. We have already discussed this same expression in the theory part. Okay, so using this now, mass of zinc upon equivalent mass of zinc must be equal to mass of silver upon equivalent mass of silver, right? So we already know, so mass of zinc will be mass of silver upon equivalent mass of silver multiplied by the equivalent mass of zinc. So mass of silver is mass of silver was 1.45 gram, I think, 1.45 gram divided by equivalent mass of silver was 108 and equivalent mass of zinc was 65.3 upon 2, right? So from here you can get the mass of zinc that is formed. So it will be 1.45 multiplied by 65.3 divided by 108 divided by 2. So it's going to be 0.438 gram approximately. Okay. Similarly, you can calculate the mass of copper also. So mass of copper will be mass of silver from these two, obviously from these two, this one and this one. From these two you can calculate the mass of copper. It will be mass of silver upon equivalent mass of silver multiplied by the equivalent mass of copper, right? So it will be now 1.45 divided by 108 multiplied by 63.5 upon 2, right? So this is how you can calculate the mass of copper. So 1.45 into 63.5 divided by 108 divided by 2. So it comes out to be approximately 0.426 gram. So that's your answer. Okay, so I hope you liked the video. This much for this video. If you want me to discuss anything else, you can let me know. I will definitely make a video on that. Okay.